Good afternoon students. Now we can see how does the equations of motion changes for freely falling body. So free fall equations. Free fall equations. Okay students. So that is free fall equations, that is kinematic equations. Okay students, now we know that for a freely falling body, so free fall body, free freely falling body, so we know that initial velocity is equal to 0 and a is equal to plus g and displacement is equal to height. Okay, displacement traveled is equal to height, we have to write it. Okay students, now see students, I am considering a free fall body. Consider this is an object, this is an object or a stone, this is an object or a stone, and it is at a height, it is at certain height from the ground, this is the ground. This is the ground level. Okay students, so fine, see the object is falling in this direction. Okay students, this is an object, it is falling in this direction. Okay students, so for a freely falling body, initial velocity is equal to 0, and also we will write initial velocity u is equal to 0 and a is equal to plus g, so you know that, and displacement so how much displacement it has fallen, so that displacement, and it is also in a particular direction, so it also becomes it can call a distance or it is also displacement, it is called height fallen also, you can call height or the displacement. Okay students, so now how does the first equation changes, you see, first equation is v is equal to u plus at. So first kinematic equation, so what is that, v is equal to u plus at. Now v is equal to initial velocity 0. Okay students, a value g and t, so means the equation has changed as v is equal to g into t. This is the first kinematic equation. Okay students, means for a freely falling body, if they ask you the velocity after t seconds, simply we can use v is equal to gt, and since g is constant, okay, since, so what can I write students, since g is constant, since g is constant, v is directly proportional to t, so velocity is directly proportional to time, you will get. Okay students, means, so this g is constant, velocity after some time they will ask you what is the velocity of a freely falling body, after certain time they will ask you, so you use v is equal to gt, and as time increases velocity increases, and this g is constant, this t is multiplied by g, means if you plot a graph, okay, and if we draw a graph, so that is what, see students, if you take a graph, so velocity I have taken on the time axis, y-axis, the time is on the x-axis. So 0 seconds, velocity 0. 0 seconds, object is at A and it is falling in this path, you know. Okay students, as time increases, velocity increases. So it is a linear proportion. So we have the linear proportionality. So 0 seconds, 0 velocity, this is the point and this is the line which passes through origin, and this line makes some angle. Okay students, and now if I drop a perpendicular, so see students, 0 seconds, 0 velocity, this is 0 comma 0, origin we know, so that is 0 comma 0. After t seconds, the velocity is some v, you take it students. Okay, now if you write, this is the opposite side and this is the adjacent side. Okay students, see, so now if I write tan theta here and if I write tan theta, so opposite side, this value is b, from here to here this value is b, so this is also b, and this is called tan theta is equal to, you will have opposite side v by t for freely falling, so v by t means it will become acceleration due to gravity. Okay students, okay students, so velocity of the freely falling body after any seconds. So this is the velocity of the freely falling body after t seconds. If I ask you velocity after 1 second, you should write v1 is equal to g into, so that is time 1 second. Velocity of a freely falling body after t seconds. The t I have taken 1 second. Then v1 is equal to, you have to take g. If g value is 9.8, then write it 9.8 meter per second. Or if you take 10, it will be 10 meter second per minus 1. And velocity of the, or 10, or you can take 9.8 meter per second square also. Okay, and the velocity of the freely falling body after 2 seconds. Okay students, after 2 seconds I am asking, then v is equal to g into, okay, what will you write? So 2, then v2 is equal to, you will get 2z, then 2 into 9.8 you will get. Okay students, 2 into 9.8, you will get the value 19.6 meter second power minus 1. And similarly, velocity of the freely falling body after 3 seconds, you will get 3z. Then that is 3 into g value is 9.8. So 3z means 3 into 9.8. You will get this is 29.4. 29.4 meter second power minus 1. See, velocity after 1 second, 1 into g. 1 second, 1 into z. 2 seconds, 2 into z. So velocity after 2 seconds, 2z. Velocity after 3 seconds, 3z. So 3 seconds, 3z. And similarly, velocity after, okay, 10 seconds if I ask you, you have to write 10 into z. So then 10 into, if g value is 9.8, you will get 98 meters per second. This is the, so means, for example, they'll ask you, an object is dropped freely, or if you leave from your hand, it is a freely falling body, and it takes 10 seconds to reach the ground. It has taken 10 seconds to reach the ground. Find its velocity. With what velocity it is hitting the ground, they will ask you. So it will come and hit the ground with certain velocity. That velocity they will ask you, v10 they will ask you. So then velocity after 10 seconds. Velocity after 10 seconds formula is what? For a freely falling body, u value 0, a value gt, so you will get 10z. So 98 meters per second. Okay, like that you can calculate velocity after any number of seconds. Okay, this is the velocity equation for a freely falling body. Okay students, now see, and this is our freely falling object. This is the point A, and here initial velocity is equal to 0, and it has taken t seconds to reach the ground. Okay, then how much displacement it has traveled is the question mark, and while it is coming down it has an acceleration, and this g is constant, so it is a uniform acceleration. Whenever object is moving with uniform acceleration, our all kinematic equations stands valid. So then I am writing s is equal to u into t. So that is this term will become 0 because u is 0. 0 into t plus half a means g, a means g, s means you can write h also. So half g t square. So this s you write it h students. Then h is equal to, what do we got it? Half g t square. Okay students, then height is equal to half gt square, you got it, and this g 1 by 2 into g is a constant, then height fallen is directly proportional to t square, or this s is equal to h no, so the distance covered, or the distance covered is directly proportional to square of the time. So s is directly proportional to t square, and this is a constant, you know. Okay students, and if you plot a graph between s and t square, you will get y is equal to ax square, you will get a, so s is directly proportional to t square, then you will get a curve, that is you will get a curve. If you plot a graph between s and t square, you will get a line like this. Okay students, the height fallen, so what's the formula? I got it. So h is equal to half g t square is the formula, I got it. So what is that? H is equal to half g into, okay, t square is the formula, I got it. So means, for example, an object is dropped from this point A and it's reached to the ground, and the time value they have given. So find how much height it has fallen. Find how much height it has fallen. If they ask you, use this formula students. Then h is equal to 1 by 2 into, if g value they will give 10, take it 10 into, use it t square, then you will get the height. So 10 by 2 means it will become 5 into t square. Okay students, they are telling, so what is the height fallen? For example, this is the piece of chalk and I have dropped, and while I was dropping, I will on the stopwatch, or I will see the time in my watch, and I know the time, after what time the sound is producing when it is striking the ground. If you know the time, for example, the time is 6 seconds. This is the chalk piece I dropped and it has taken 6 seconds to reach the ground. Then this height, how much height it has fallen, to know that. So 5 into t square value, it has taken 6 seconds time, 6 square, then 5 into 6 square you will get 36. So you will get the height fallen, you will get the height. So that is 5, you can calculate 5 6 is 30, 0 and 3, 5 3 is 15, 15 plus 3, so 180 meters. So the height fallen is h is equal to 180 meters you will get. So like this you can calculate. So the formula to find the height is h is equal to half gt square for a freely falling object. How much height it has fallen, that's the equation you have to use it. And similarly, in the same equation, h is equal to half gt square. If you do the cross multiplication, so we will get 2h. 2h is equal to g into t square. Okay students, 2h is equal to g into t square. Then t square is equal to, you will get 2h by g. Okay, so then, so time value you will get t is equal to t square, this is the formula, then t is equal to, so what will you get students, root over 2h by g. So means if you know the height, from what height we are dropping the object, if you know the height is known, so h is known and g value is known. Okay, and then how much time it takes to fall, to reach the ground, they'll ask you the same formula used. So in this h is equal to half gt square formula, h is equal to half gt square formula. So make t subject, now you want t. Okay students, then 2h by g, so 2h by g is t square, then t is equal to root over 2h by g. So with that so then 2 into height value is 200 meters. For example, suppose height is 200 and g value is 10 seconds, 10 meter per second square, then time taken you will get, for example, you dropped from the height of 20 meters. You dropped from the height of 20 meters and asking the time, this 0 gets cancelled, 2 into 2 4, so it takes 2 seconds. So out of the root 2 seconds, like this you can calculate. Okay students, similarly you see the third equation. What is that students? V square minus u square is equal to 2as is the equation. Okay, so you are dropping freely falling body, u is 0, so u square term is 0, then v square is equal to, we will get 2 into a value g, s value h. So then you are getting v square is equal to 2gh, then you are getting v value is equal to root 2gh. Okay students, then v value you are getting, v velocity on reaching the ground, you are getting v is equal to root 2gh. Or you can make h subject, if you make h subject, h is equal to velocity on reaching the ground by 2g. Okay, so you know initial velocity is 0, v square is equal to 2gh. So a value g, s value h, then h is equal to v square by 2g. So you have how many variables in this equation? You see students, the number of variables in the equation is, so v, g, h. Okay, h or s, displacement fallen or distance fallen, so that is called h. So if any two are known, okay, this any two are known, you can make the third one as an unknown. Third one, that unknown as a known. So this is the equation, you remember students. Okay, and second equation also we know, you see students. So what is the second equation? You know s is equal to ut plus half a t square is the equation. Then s is equal to h, ut value 0. So what can you write? Half g t square you can write. H is equal to half g t square we have written. Okay students, that is called heights fallen or the displacements. So then you also know that s is directly proportional to t square. Now I want to know the distances travelled, the ratio of distances travelled in 1 second, 2 seconds, 3 seconds, like I want to know the ratios. So ratios of, so now see students, ratios of, so what is that? Ratios of distances travelled. Ratios of distances travelled, ratios of distances travelled in, so 1 second, so 2 seconds, 3 seconds, etc. Okay, these ratios we want. We know that the ratios of distances travelled, h is equal to half gt square, you know, and this is a constant. The constant term gets cancelled in the ratio. S is directly proportional to t square, you know. Okay students, then ratios of distance traveled for first 1 second, 2 seconds, 3 seconds means 1 square is 2. So what will you get? 2 square is 2. So 3 square and 4 square. So etc. you will get. So 1 square means 1. So 2 square means 4. 3 square means 9. 4 square means 16. These are the ratios, distances ratio, that is 1:4:9. So these are the ratios of distances travelled for a freely falling body. So means you want distance with respect to time. Here also you see the number of variables h, g, t. The number of variables are h, g, t. If any two are given, you can calculate the third one. And here also v square is equal to 2gh. This is also distance on reaching the ground. So that h you can write v square by 2g. Means if you want the distance in terms of velocities, final velocity is given and g is given. This is the formula used. And if you want the distance in terms of times, use this equation, students. Okay. Okay, students. Now height fallen in the nth second. So Sn is equal to u plus a into, what can you write? N minus 1 by 2. And the same you can write Sn is equal to u value 0. So you are writing 0, a value g. Okay, n minus 1 by 2. We can also write 2n minus 1 by 2 by taking LCM. So then Sn is equal to, what will you write? Sn is equal to, so g by 2. So g by 2 into, what can you write? 2n minus 1. So you can write like this. This is the distance. This is the height fallen in the nth second, or distance fallen in the nth second. Hn or Sn is equal to, so g by 2 into what will you write, students? 2n minus 1. You can write it. So this is called Hn or Sn. Hn or Sn is equal to, so like this we have written. So now and this g by 2 is a constant, then height fallen in the nth second, Hn is directly proportional to, so height fallen or the distance fallen in the nth second is directly proportional to, so Hn or Sn, which is directly proportional to, what can you write, students? 2n minus 1. So for example, for here to here 1 second, and here to height fallen in the first second, second second, third second. So what is the distances fallen? Distances for freely falling body for, so what is that? Freely falling body, for freely falling body, for freely falling body, heights, that is distances traveled, for freely falling body, distances traveled in first second, distances traveled in the first second, second second, third second, etc. So every one is 1 second only, that is in successive intervals of time, that is in successive, so equals in successive equal intervals of time, in successive intervals of time, in successive equal intervals of time, in successive equal So intervals of time. So for freely falling body, distances traveled in the first second, second second, third second, etc. in successive equal intervals of time, I want to find it. So that is, you know that distance fallen or the heights fallen, Sn is directly proportional to 2n minus 1. So Sn is directly proportional to, okay, what is that? 2n minus 1. So first second means n value 1. Okay, then 2 into, so you write n value here 1. So 2 into 1, 1 minus 1, 1. And n value second is second. So then n value 2 you write it. 2 into 2, 4. 4 minus 1, 3. 1 is 2. 3 is 2. Similarly 3. 3 into 2, 6. 6 minus 1, 5. So 1 is 2. 3 is 2. 5 is 2. And in the fourth second, 4 into 2, 8. 8 minus 1, 7. So like you will get, these are the ratios, okay, etc. you will get. These are the distances travelled in the successive equal intervals of time. First second, second second, third second. Everyone is 1 second only, but distance fallen in the second second. So that is 3 times. Means in the first second, if it travels x distance, in the second second it travels 3x. Okay, in the third second it travels a distance of 5x. Okay, and like in the fourth second it travels a distance of 7x. So that is second. See students, for example, this freely falling body takes 0 to, so it takes 0 to 5 seconds to reach the ground. 5 seconds. 0 to 5 seconds means the counting will be like this. 0 to 5 means 0 to 1, so 1 to 2, so 2 to 3, 3 to 4, 4 to 5, these are the 5 seconds. 0 to 1, first second, in the first second if it travels x, then 1 to 2, this is also 1 second only, but this is the second. This is also 1 second, but this is the second. In that second it travels 3x distance, in the third second it travels 5x distance, and in the fourth second 7x distance. That is called, this is successive seconds, successive equal seconds, successive equal intervals of times. So the distance or the height fallen in the ratio 1 is to, 3 is to, 5 is to, like odd numbers you will get 9 is to, because 2n minus 1, you take n any number, it is multiplied with 2, so you get even. So the process will become like this. Okay students. And similarly, we know the second, so we know, see students, we know the second equation. So that is h is equal to half gt square, you know the formula. So height fallen in the first second, if I ask you, so what you write? 1 by 2 g into, you write 1 square. So, and similarly, height fallen in the 2 seconds, if I ask you, 2 seconds means, so this is the height fallen for the first second. Height fallen for the first second, height fallen for 2 seconds means this total time will come. 2 seconds means 0 to 1, 1 to 2, totally 2 seconds. Height fallen in the 2 seconds means 1 by 2g into, you can write 2 square. Okay, and the height fallen in the height or the distance fallen for 3 seconds. 3 seconds means counting will be like this. 0 to 1, 1 to 2, 2 to 3. This is called totally 3 seconds. Whenever I say 3 seconds means 0 to 1, 1 to 2, 2 to 3. It will, counting will come like this. If third second I will ask you, after 2 seconds, your counting will start 2 to 3. This is only 1 second. Distance traveled in the third second. This is third second. Third second means you should use, this is the formula. So that is, this is the formula you have to use. For 3 seconds means you have to use the formula half g into 3 seconds, you write it 3 square. Okay students, then take the ratio of h1 is to h2 is to h3. Take the ratio of h1 is to h2 is to h3. So then in all the ratios, this half g cancel. 1 square is to 2 square is to 3 square. So the ratio you will get 1 square is to 2 square is 2. What will you get? 3 square. 1 square means 1, 2 square means 4, 3 square means 9. So 1 is to 4 is to 9. But here first second, third second, 1 is to 3 is to 5. Like these are the distances fallen. Okay students, so what is acceleration due to gravity? You know that, and freely falling equations also we have discussed very clearly. See my dear students, you write the equations on the paper and convert them, and for every equation you come to know the meaning first of all, and for every equation you do some problems and write the equation in terms of words, and 1 to 20 problems. So from exercise today you try 1 to 20 problems, and the difficulty questions you post for me, I will teach to you, and some models I will cover to you now. Okay students, so you please practice. Here I am in front of you to just guide and say and give a coaching only. So the rest of the thing you have to run. Okay, so we will make you to run, and we will support you for that running, and we will give you the tips, and we will give our experience with the help of the management, and what is your desires and your parent desires. With that, the management is every time encouraging us, principal sir is encouraging, and physics HODs are also guiding. So you please keep solving the problems and write the equations, and difficulty problems you post for us. How to do we will tell, and if it is a difficulty problem and what to do we will tell for you. So you are not getting any problem, don't get disappointment, leave that problem, so and go for the next and for the next, like that you proceed one by one. Okay, keep solving, you will get. Okay, we will go for problem number. So now we will go for problem number, that is 3. So what is that? See students, 1 and 2 already covered in the concept. Please do it as a homework and tell to me. Now problem number 3. What is that? A body is allowed to fall freely. So a body is allowed to fall freely. After 2 seconds, another body is also dropped freely. The relative velocity of first body with respect to the second body they are asking. Okay students, so now see the solution for third problem. A body is allowed to fall freely. So there are two objects. First object and so there are two objects. So which are first object and second object. Okay. Second object is dropped 2 seconds later the first one. Okay, means the time interval between them, since both the objects are freely falling bodies. So this is dropped first and it is dropped 2 seconds later of first body. Means at any instant of time, so the time interval will remain constant. So the time interval, so the time interval between two objects, the time interval between the two objects remains constant. The time interval between the two objects, so what is that? Remains constant, that is 2 seconds. Okay students, that is 2 seconds. Okay. Okay students, then they are asking the relative velocity of first body with respect to second body. Find the relative velocity of the first body with respect to second body. So next what I am writing is students, let V1 and V2, let V1 and V2 be the velocities. Let V1 and V2 be the velocities of, so what is that? first and second body. Let v1 and v2 be the velocities of the first and second body at any instant. At any, what is that, instant of time. At any instant of time. So let v1, v2 be the velocities of the first and second body at any instant of time. Then velocity of first body, I want to write it. So velocity of the first body after t seconds, I want to write it. So velocity of the first body after t seconds, v1 is equal to u plus freely falling body, no? So g into t. So you know that. So v1 is equal to, so g into t. And similarly, velocity of the second body. This is also second body, also freely falling body, you know, initial mass is 0, g into, and for this time is t minus 2. So you should get the time difference between them is t minus 2. Okay students, means for the first body the time is 4 seconds. For this object the time is 2 seconds. Because this is dropped 2 seconds later the first object. So first object is dropped, it is reached to somewhere, and after that second body we have dropped 2 seconds later. So the time interval should remain constant. Okay, this is the first object velocity, this is the second object velocity. And since it is a freely falling body, so this v value is 0. So v is equal to u plus 80. This u value will be 0, you will get. So velocity of the first body after t seconds, v1 is equal to gt, and second body is g into t minus 2. So this is velocity equation, and these are the velocities at any instant of time. Now what the question is, so they are asking to find relative velocity. Find, so what is that? Relative velocity. Find relative velocity of first body. Relative velocity of first object, first body. So with respect to, second body we have to write. So that is the thing we have to find it. So now the relative velocity of first object, with respect to second, v1 to 2, that can be written as v1 minus v2. v1 means we will write g into t minus v2 means, so what we write, g into t minus 2. Okay students, so this is the formula for relative velocity. Velocity of first object with respect to second object means velocity of first body minus velocity of second body. You have to do the vector subtraction. Okay, v1 minus v2. Okay students, and since both the objects are in the same direction, both velocities are in the same direction, so you will get a direct v1 minus v2 only. So then this is called gt, and here, so minus gt and minus of minus plus 2 into z to z, g into t, gt, g into 2 to z. So and this minus also there, and this gets cancelled. So then you are getting, so velocity of first object with respect to second object is equal to, we are getting 2z. Okay students, so there will be a difference of 2 times of acceleration due to gravity between the two objects while they are falling.